to this meaning, and later environmental issue and to the influence of soil on human and animal health. And nowadays we have, so since 2010, we have multifunctionally meaning, which include also ecosystem services. And it's also possible because we can use a lot of digital applications for calculating a big amount of data. So this, we can say that now soil quality can include ability to sequester soil carbon. And but how it can be done in reality, we have atmosphere. We have some amount of carbon in the atmosphere. It was calculated, and so the mean value is 750 pentagram, or 750 billion of tons, let's say. Also, we have some amount in the vegetation which are currently grown on the planet, and it was also calculated that in the soil, in the top 1 meter depth, it is 1,400. And deeper, we have even more, 2,000 and a half, totally accounted for 4,000 pentagram of carbon in the soil. So using the photosynthesis through the plants, and also applying crop plant residues, and adding some manures from animals and so on, so we can increase the amount of carbon in the soil. But the problem can be when we have also different land use types. So, for instance, we can overuse agrochemicals, we can use monocropping instead of crop rotation, or in extensive soil compaction due to tillage and many operation on the field, or we can use more sustainable soil management, which includes reduced tillage and implementation of crop rotation, and moving to more sustainable. Therefore, soil can contain up to 8 times more carbon, and to do that we need to move from intensive agriculture to more sustainable agriculture. So, and this how we can do this sequestration. It cannot be done in any case, only if we change our way of agriculture. Then also, when we look at the global distribution of soil organic carbon, we can see that it is not evenly distributed in the region, and we have the highest amount in temperate and tropical zone. Also, when we check the land cover, it is more under the soil, the forest, shrubs, and crops. And as for soil types, we have the biggest amount so organic soils, or in Ukraine we have them like peat soils, I think, and Chernozems. So, and also, of course, it just because the size of the country, we can different possibility for different country to sequester it. Therefore, we need to look. We would like to save more soil carbon, so to mitigate climate change with using of soils, we need to check the climate, land cover, and soil types as well. So, and now I would like to tell you about one initiative which was launched by French government during the Paris Climate Summit in 2015. And it's called 4 per meal, or 4 per 1,000 initiative. And according to that, the government of France would like to boost carbon storage in agricultural soil by 0.4% each year, and to help mitigate, to help with both mitigate climate change and also increase or at least sustain food security. And so this year, It was a meeting during which they decided so the real guidelines how they will do it until 2015. And so I need to mention that this is not so unless it was adopted or it was launched during Paris Climate Summit. A lot of people from different countries participated, but this initiative is implementing now in France, Germany, and Spain mainly. But anyway, so this is a good way how we can solve two problems of food security and climate change using agricultural soil. But I would also mention that we should check for sequestration potential. So we can have sequestration if we have high input of organic carbon to the soil and lower output, or if we have the other way around, we will have the loss of carbon. And also this ability to sequester carbon increased from arable land to peatland. And to be objective and not to apply it anywhere where you would like, we need first to check if it is feasible, if we have a real a real possibility to do that. Then also the agenda just maybe a few months ago published in the Nature, and they propose, so the scientists who actually launched this initiative, they propose to do this in such a way. So first we need to check for sequestration potential. If it is high, so if really can increase it, we should act later. If not, we don't need to do something with the soil. And the next step is to check if we can increase the yield, so the harvest potentially. For most of European countries, it's not the case anymore, so they have the highest yield they can achieve. And if it's not possible on some place, so on some land, the escape, so we should also check another benefits and don't do something. If yes, then the next step is the soil degradation. And also, if it is a high soil degradation, and then this agenda should be applied. So thus, when we check for sequestration potential, we need to take into account environmental and socio-economical issues as well. And how it is done, so for that we need to understand that this is kind of stabilization process, and we need to add plant residues, to add some organic materials, and to control organic matter decomposition, because this is a cycle, this is a constant process, so this is a continuous process. And soil organic carbon can be increased, but to reach equilibrium. On this graph, you can see the equilibrium, and only by reaching this, so we just can maintain it, and it's not possible to increase it anymore. And what is also very important, and we need to take into account, that first 25 years, we will have much higher effectiveness than totally in the next 50 years. And the cumulative carbon input will be much higher to reach this additional amount of organic carbon. So, and then this also should be clear. So that's, we need to add crop residues, organic fertilizers, to increase or at least stabilize soil organic carbon and decrease the composition. And also we need to be aware about the effectiveness, that first 25 years we will be more effective, and the next 25 less, but with more input. And now I would like to tell you a few case studies from France and from other. So first two from France. This experiment has been done in France, in Lusignan. It's the southern part of France, and so they were a grassland, and so they applied two different land use management, grazing or mowing. With the grazing, so there were cows on the grassland and they eat this grass directly. And with mowing, this grass was cutted and then removed from the field. And this type of land use management has been done for 12 years. And then after that, grazing was more preferable for soil microorganisms, which you can may see here, they are happy, and I mean, they were not happy. It's not possible to determine if they're happy, but they produce a lot of enzymes, and they were more abundant in that soil than in soil under mowing. And also it means that we had higher potential, so that there is high potential for carbon mitigation on this soil, and soil organic carbon increased from 1.46 to 2.19. So in grazing during this 12 years. And another study in which I participated by myself, it was also done in the same region in Lusignan. So they organized their experiment, and previously in 2005 they used that field for permanent cropland. They plant only crops. Later, so in this year, part of this plots, on part of these plots, they so they introduced grassland, and this land was under the grassland for this 13 years. And they add also another treatments. They introduce grassland to cropland. So 3 years of cropland, wheat, barley, and maize, and 6 years of grassland, and so on. So it was a cycle. And also they add nitrogen, or they didn't add a nitrogen to grassland. So this was the difference. And in this 13 years, after this changing, land use changing, so the amount of soil organic carbon on permanent cropland was about 1%, and then it increased in permanent grassland, then a little bit less, but still high in temporary grassland with nitrogen, and much less without nitrogen. So it means that soil organic matter increase gave us additional 0.65% of soil organic carbon when we convert cropland to grassland. And if we introduce grassland to cropland, then with nitrogen addition, we have also comparable value, 0.5%. But if we don't add nitrogen, it's only 0.18. So it means that grazing has more potential for carbon sequestration, and introduction of grassland into cropland can be a compromise for food security and carbon sequestration. And another case study comes from Switzerland, was sampled from 4 farms there, and subdivided into 3 categories: conventional, land use, no-till, and organic. And then we can see, so on this, actually here, we can see that we have higher increased carbon root input to organic. So if we move from conventional agriculture to organic agriculture, but we didn't have any significant changes. We didn't see it on in a subsoil. So it was more or less stable. Therefore, so scientists, the authors of this paper, also it was published recently, they would like to recommend to plant some plants with a deep root system, and then to increase the amount of subsoil carbon in this way. To conclude, move from conventional to no-till organic carbon can be easier. It can increase soil organic carbon. And also we need to look for crops which form their deep root system to increase it as well. And the last, maybe it's not a case study, but just so maybe some compromise how we can, and what we should take into account when we are talking about climate mitigation with the soil, urban soil. So as you see here on this first image, so we had previously on the planet mostly croplands, and then during urbanization we converted to different type of so big cities, small cities, towns, and so on. And then it also contains, so in the city we have a lot of carbon, as you may see here in another image, and it was estimated that each century we have about 50%, 50 centimeter more soil layer, cultural layer, and it was also suggested that soil organic carbon stock in these medieval cities in the first 2 meters is higher than maximal in any Chernozems was found anyway in the on the planet. Why we need to also take into account the urban soil, because it is 2.5% of global coverage. Also because we have soil organic carbon 3 to 5 times higher in urban ecosystem than in natural. And because this is a lot of carbon which can contribute it up to 13% of total carbon sequestration. So that's all what I would like to tell you today. Thanks a lot for your attention, and I will be very happy to discuss this data, and will be happy to listen to your question.
Thank you, Natalia, for a good presentation. It's a very interesting topic about organic matter restoration, about investigation of how organic matter will impact on soil safety, soil quality parameters, and as well as food safety in the world. Because it's a very important topic. You mentioned that that in developed countries in Europe, in Germany, Switzerland, etc., they already achieved the maximum possible yield for most crops. So is that the result of such kind of actions for soil carbon restoration, or there are other reasons, other factors that have impact on it?
So if I understood it correctly, I think now that's why they would like to adopt this 4 per meal initiative. So they would not opt for a high yield, but they would like to use soil more for carbon sequestration, because food is not so expensive, and sometimes it's cheaper to buy food from other countries, but to use their soil more healthy, let's say. But this, if we're talking about carbon sequestration, this is a global problem. So it cannot be achieved only with effort of one country. It should be done by all countries all over the world. But still, till now, it's not a case for developing countries, because I think in developing have a little bit different problems, and it's not the case.
Yeah, thanks. I agree with you. Other questions? Do some participants have their questions to Natalia? So there is no other questions. Thank you, Natalia, for very good presentation on the topic you outlined. Very interesting to know the results of such experiments.
Vyacheslav, I saw the hands up from Elena.
Yeah, Elena, you can ask your questions now, please. You're welcome.
Thank you, Natalia. I've got just one question. Do you have any case study on urban areas connected with your research? I'm talking about urban areas.
No, I mean, I didn't do it personally. I took it from the papers. If you're interested, I can, so you just can check it. So the one paper was in Landscape and Urban Planning, just published a few months ago. Another one 2 years ago in Land Development and Land Degradation. And in these papers, they are like a review, and they review the possibility to use urban soil for sequestration, for carbon sequestration. So, and I think this is important topic, because maybe if you would like to know deeply, I think there are a lot of references in these papers which you can just read later, check the references. But I didn't do that. I'm working with agriculture, so I'm from agriculture university. That's why, yeah, I prefer agricultural soil.
Okay, thank you.
Yeah, you're welcome.
Thank you so much. Any other questions to Natalia? Okay. So I hope that Dr. Chetin is ready for his report. And do you think the problem is microphone?
Can you hear me first?
Oh, yes, great. Super, super.
Really? Okay,
Yeah,
good.
yeah, that's very good.
No,
Finally,
actually
I
there
hope.
was no problem, but what happened, I don't know. Okay, anyway. Okay, we can start, yes.
So I will share your presentation and
Right,
you
okay.
can tell me where to switch
Okay,
your
right,
slides.
okay. Okay, may I start
Yeah,
now?
you may start now, please.
Okay, thank you very much. And good afternoon to everybody from Turkey. I am joining from the Dicle University, south of Turkey. And first of all, I would like to thank Dean of the Professor Taras Levskiokov, Dean of the Land Management Faculty. And secondly, also I would like to thank Associate Professor Vyacheslav Bagnatis. Okay. My presentation is some problems and experiences and on the soil and water conservation in Turkey. Okay, next please. Okay, next please. Okay, as you see, this map was all the worlds and show about that with using the irrigation water in the world. And the south of all the worlds, as you see, including the Turkey, is huge amount of water using for agricultural purposes because it's arid and semi-arid regions. Okay. Next, please. Next, please.
That's a bit lag.
Okay. Also, this is the soil degradation maps, also including all the worlds. As you see, the dark brown shows that very degraded soils. Degraded soils, especially salinity, loss of organic matter, fertility decline, soil acidity and alkalinity, and soil contamination and structural decline. It means that we are unlucky to, especially as a geographical in Turkey, as you see this map. Okay. 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 And just very shortly, Turkey is a big country. Also, we've got three main climate zones. One is the mainly continental, and also including Mediterranean climate zone. And the total precipitation is changed to 150 millimeter per year up to 2,500 millimeter. However, 90% of the whole country and semi-arid, of course, some parts, small parts are arid zones. It means that less than 300 millimeter per year, right? Okay. Next. Okay, this map also shows that about the altitude, the map, and because Turkey more than 50% of the mountains area, totally more than 1,000 meter, right? Okay, next, please. Okay, now is related these issues. Our web seminar is agricultural farmland is decreasing year by year, and it's disappear where Vyacheslav. Okay, now is okay. And agricultural lands decreasing year by year, unfortunately. Before, please. And about the 90s, we've got about 28 million hectares agricultural lands. Unfortunately, nowadays, 24 million hectares just on. It means that more than 4 million hectares increased because of industrialization, tourism, transportation, urbanization. The secondly, of course, is that some farmers don't want farm because of the some high cost, and also because of the immigration from the rural area to urban or the cities, right? Okay, next, please. Okay, these pictures is arid and semi-arid region is very important issues and soil erosions and also deforestations and some others. Next, please. Other overgrazings and also is very important in the country. Also, this is the mismanagements, we can say, the lack of these issues about that, right? Next, please. Because I want to speak speedily because the time is very restricted, and this is the in this country is very important. One is the burning stubble, especially the after harvesting of the field crops. And although there are many regulation and law and high penalties, unfortunately, we couldn't overcome these main problems because the farmers and wants to plant it easily and plugging at that time. So firing this like follow is made the problem in that area. Yeah, I think as you see, this is the main problem is it could be by the topography and climate. We cannot change, of course, but we can do, and considering the topography and climate change about management and other practice. And the other, the human being also is very important, human effects. So it's all the negative effects coming from by us, I mean by human being, right? Next, please. And in Turkey, about each year, the forest fires is important events because each year approximately average more than 2,500 forest fires event. And unfortunately, we are losing about 5,000 hectare forest area. Fortunately, all the governments decided to about afforestation approximately each year. We edit about more than 40,000 hectare forest area, new area. In Turkey, about the 90s, just we've got only 20 million hectares. Nowadays, 22.6 million hectares forest area. It means that even if it is slowly increasing year by year forest area. Okay, next, please. Okay, and irrigation is very important in arid and semi-arid regions. Maybe it's not Ukraine or the northern European countries, but like including Turkey and the other countries is very, very important because rain-fed conditions provide to farmers about $500 per hectare gross income. After irrigations, and any farmers can get about more than 6 times. It means that $3,000 per hectare. It means that 6 times more. It's very, very important. And also to provide to food also is very important by means of irrigation, right? Next, please. However, even if the use is important irrigation in Turkey also about 20 years ago, more than 90% of the irrigation is the surface irrigation, including the flow and flood irrigation. As you see this picture, top of these two pictures is real pictures that where I studied here. So after that irrigation event, you can see very dramatically soil water erosion issues. Siltation also is the canal systems. The bottom of the pictures shows that about also some slopey areas, including the rainfall and also irrigation effects, right? Next, please. Okay, after that happens, what happens? Because the water locking is the very big problems and also drainage problems, and after that salinity and alkalinity. I would like to say about that something like that. In the world, many societies based on the irrigated agriculture have failed in the history. One is the Mesopotamia, including south of Turkey, and for instance, Viri Valley, Peru, is in the history. And nowadays is flooding, over irrigation, seepage, silting, rising, and water table is the main issues and main problems and some arid regions, not only in Turkey, the other countries also. In the world, 10% of the total arable lands affected by salinity and solidity. If we consider the whole irrigated area in the world, it means that 25 or 30% of irrigated lands are salt affected. It means that we are losing year by year and high fertility soils. It means that annual economic losses, according to a calculation, in all the world, we are losing about 30 billion US dollar each year. So it is very important. It's not only the economic, but also and soil and water resources we are losing year by year, right? Next, please. Okay, this is the real picture at the 20 to 30 years ago in the arid and semi-arid region in Turkey. And also Turkey has a similar figures as well in the world. 20% of the irrigated area, unfortunately, is salt affected, right? Next, please. Okay, after all these problems, fortunately, government decided about 15 years ago in Turkey and decided to subsidize the farmers who want to use pressurized irrigation system. It means that modern irrigation system, drip irrigation and sprinkler irrigation systems, at least 50% of the whole investment cost government gives the farmers. Of course, is under control and depending on the some properly project, right? Next, please. Okay, in Turkey, also related to organization, the soil and water resources, on the top, there is a Minister of Agriculture and Forestry. Under the State Hydraulic Works, this government organization responsible directly the whole country, especially the water resource management and development situation. And the other, there are some NGOs, non-governmental organization. Maybe some of you can hear TEMA is very effective studies and works about that in the rural area. And also we are getting some projects and development agencies and European Union, also World Bank projects, and by means of financial support to rehabilitation and watershed development. Next, please. Okay, this is pictures the big dams, also Atatürk Dam south of in Turkey, and by means of that, about 2 million hectare will be irrigated. And others pictures shows that some rehabilitation projects and forest area. Next, please. Okay, now is the very rural areas, some projects, canal system. This picture shows 22 years ago, also you can see there, we are constructing the small canal systems, especially the far rural places, because it's very important to fix establishment of any inhabitants in the rural area. Is very important. The government all time support these small canal systems and irrigation pool system and other rehabilitation projects, some small watersheds, right? Next, please. Also, you can see these pictures. We can skip, please, this picture. Okay, next, please, Vyacheslav. Okay, I would like to show some figures about after that projects, because it means that by providing some financial projects, World Bank, what happened after that projects, household incomes increased more than 50%, let's say soil fertility 30%, vegetative cover in 70%, something like that. It means that we can consider the very successful about that rehabilitation projects using some different watersheds, right? Next, please. Okay, this is some pictures and rehabilitation you can see everywhere in the internet also. Next, please. Okay, we can skip also. You can see same picture about some rehabilitation. Okay, this is important projects in history in Turkey. Maybe some of you knows, but it's important because in the history, I mean in 1960s, in the central of Anatolia, near the big city, the Konya, there was about 15,000 hectare area, is very dramatically high wind erosion area. All the sand movings. At that time, government decided to change the big town and more than 10 village places. However, after that, rechange consideration, the government decide to develop in soil development that area. Next, please. What happens these projects? The first time, the construction of some fence to prevent move of sands. Second step is seedling and plantings all that area. Which crop types is adaptable for that area? And third time is little bit forest area, and that time likes that. It means that it takes about more than 10 years. It's very successful projects, that area. All the area wind erosion area at that time. But some foreign peoples and scientists and also students come and visit that projects. Next, please. Okay, now is that area is a dry farming systems continue, and some orchards and also rangelands possible, right? Please, next, please. Okay, after that projects and sense about afforestation, more than 4,000 hectares, you see some pasture and vineyard, all we are using the effectively and fruitful as a farmland now. Okay, next, please. How about the time is the Vyacheslav? Is okay time? Okay. Next, please, because I would like to skip a little bit more, because I don't want to get
You
more
have
time.
5 minutes, so
Really?
you have enough time. 5 minutes.
Okay.
Or 4 minutes, sorry, 4 minutes.
Oh, I'm sorry. We have to, okay. Anyway, we are using the much more huge amount of water for irrigation, and if we use the modern irrigation, 6,000 cubic meter per hectare. Next, please. Little bit speed the slides, please. Okay, is it possible to use some simple devices to increase soil water productivity and irrigation efficiency? Okay, next, please. Okay, next, also similar slides, because I would like to say some summarized. Okay, next, please. Next, please. Okay. We are using some universities or also some government institution to increase the water productivity and irrigation efficiency, because it's very important, the soil and water, increasing the water productivity, economic productivity, and land economic productivity also. It's very important, because if we have to use very efficiently water resources, also including the soil, of course. Next, please. Okay. This is the summary. This is about what happened agriculture irrigation, because it's one issue is optimization irrigation systems, techniques and for improvement water, and land use wastewater, management salt affected soils, and also economic aspects irrigation, environmental health aspects of irrigation. It's very important issues, all this irrigation management. Next, please. Okay, just I would like to say a few things about this slide related to irrigation, but however, it's very important, the soil resources also. And you know, the 90s Green Revolution started. After each 10 years related to development of irrigation system or management. Unfortunately, as a human being, we became aware of the just environmental issues and sustainability on the just only 20s, because we started that, and as I said before, water erosion, wind erosion, and some soil quality increasing and other environmental problems we started. Okay, next, please. Okay, just conclusion, a few words, and I think it will be finished. And as a result, land and water management should be integrated, and management should be on basin. Fortunately, agricultural policies have increasingly focused on food safety and environmental issues since 2000. Overall, combining integrated implementation in the catchment require conservation and sustainability soil and water resources. Okay, just I finished my presentation here. You can see these pictures. We are at some big projects, Field Day and National and International. Some of you and Taras and also Vyacheslav, I know just Taras came visit our university, and also all time welcome to our some scientific events. Thank you very much.
Thank you for good and informative presentation, just in time. Do you have any questions?
Slav, can I ask you one question for Oner?
Yes.
Yeah.
Thank you. Oner, thank you for your good presentation. And now I want to ask you about the price of water. Water for irrigation in Turkey. How much is 1 meter cubic meter in Turkish for irrigation? I think in the future it will be very interesting question, because in your presentation I saw from 1 hectare the farmers can get $500, and if use irrigations, maybe 3,000. Yeah.
Yes.
Yeah.
Irrigate rate. Okay. Good question. Thank you very much. And if you explained about that, if you ask directly the cost of the irrigation water to farmers, and it can be changed from the region and regions. And I know the calculation, just 5 cents and US cent, and up to 20 cents per cubic meter, right? So, however, unfortunately in Turkey, and the whole country, most of the irrigated area, and we cannot measure directly water. It means that any irrigation schemes decided just only based on unit area per unit area and crop type. So it means that just the whole irrigation seasons just fixed cost, right? So that's why explaining that before we've got the really big problems over irrigation and waterlogging and desalination, because any farmers intend to use over irrigation, because even if any farmers want 2 times, 4 times, or 1 times, any times to frequently irrigation, and it means the same price. That's why this is the over irrigation. And it's very complex situation. It's very sophisticated, because irrigation, considering there is no only one side, not a pure science. So there are the technical science, economical science, and also social science. It's social science, including the education level of farmers, and what's your understanding democracy and irrigation cooperative, something like that, and political situation, and the attitudes and history and religions. We can consider everything. It's a very complicated situation. However, we have to do next time, but government, there is the good laws and regulation. Unfortunately, we could not over up to time.
Thank you. And what do you think about the price? Will the price for price of water will be growth in the future?
Should be growth, because
yeah.
if I say in the in between the farmers, all the farmers can be fight me. Okay, because the farmers don't want high price, but we have to do, because of course is the not one solution to improve the increase of the water charge. The one solution, not only one solution, but there are many factors, but is important factors to measure the water volumetric and to consider based on volumetric cost of the water.
Well, thank you. I hope we will continue the discussion at the end of our webinar. And now it's time for the third report. It's a mine report, so I will try to share my screen now with my report. Do you see my screen now?
Yes.
Yes.
Okay, thanks. So I will what I do really want to discuss this question, and that's one of the reason of such kind of webinar. This topic is very important for soil conservation and consistent development of the society, of food security, because soil conservation and its monitoring is very tightly connected to land use, and this is very important topic in Ukraine. It is not well developed actually. Actually, that's a part of a bigger problem. The goal of balance or so-called sustainable development, which is achieved for sure on regional and local scale by direct concrete measures. And the important point here in this global goal is the reasonable and balanced soil conservation, especially when the land is used intensively in agriculture. So in Ukraine, there is a lot of land use threats. The main of them are soil erosion, dehumidification, salinization, waterlogging, water deficiency for irrigation and other purposes, crop rotation violations, and improper agricultural management by farmers or big farms, and environmental pollution, including radiation and chemical pollution, and so on. Here on this map, it is shown that the most severe problem in the north was radioactive pollution by the Chernobyl accident. Now it's not so severe, but also a big problem. The next is dehumidification and other problem with salinization and so on in the south of our country. That's important problems that should be solved. For soil erosion, there is such kind of map that shows such margins, such borders of regions with intensive wind erosion. And here you can see the picture from Ukraine. Yes, it's a real picture from Ukraine with such a sandstorm that took place 2 years ago in 2018 in the Zaporizhia region. It's here. And here you see the destructive effect of water erosion. It's also very big problem here in Ukraine. So the next big problem is connected with waterlogging. As you see, this settlement is totally distracted by water actually. And here on this map you see the regions that suffer much more from this negative effect than others. But very important problem, that was the topic of Natalia's report, that the humus content is decreasing constantly in our country, which considered to be maybe the most rich in humus, in organic matter content in the world. And now this rate is maybe slightly increasing, but actually it's decreasing much more. We have a good legislation on soil conservation, and there is a very good measures there on conservation of degraded soils, on implementation of measures for controlling of land contamination, and so on and so on. But actually the problem is still there, and it's very important make good cartography basics for monitoring of these parameters of land use. As you see here on this map, it was shown previously, the mapping unit is administrative district. So that's one of the reasons of such kind of map, that all the statistic information is gathered on basis of administrative unit. But also this kind of approach for creating map is not so good as many of us suppose. So big problem is with the actual state of the situation with land degradation and land use in situ. So the direct place may have completely different parameters than average on some administrative districts. So it's not the best approach to compile such maps on administrative approach, on administrative districts. Also, other problem is maps, and that maps is not very young. As you see, this famous map of Ukrainian soils in scale 2.5 million centimeter. It was compiled in these years. It was very long ago. It was updates for sure until the late 90s, but we do not have actually a good map of soil cover of Ukraine for this present moment, and that's a big issue actually. Some reasons why we have a good progress now in improving, in implementing innovative services is extraordinary weather conditions. Because of them, farmers are worried about their crops, about their yield, and they use such kind of innovative techniques as drones, satellite images, and satellite monitoring of their crops. There are a big market here in Ukraine that is directed on that purpose, and a small part of that is also directed on soil conservation issues. It's very important that farmers should understand not only to achieve high yields, but also to have some measures to restore the productivity of land. And this approach is much better, as for me, comparing to regional, to administrative approach when you prepare maps using direct parameters indexes of the existing field. Another good approach is using big data. There is a big market also in the world. A lot of different companies are there, and they propose a big data set that will also help to analyze such problems, including land degradation. And some of these data are accessible online and free of charge. And there is a public lab, for example, that provides some research in land use in the US and so on. So I will switch to Copernicus Land Monitoring Service. It's a great, maybe the most innovative service we have now in the world, and Ukraine now is part of it. But also this service shows us a global picture as well as local picture. As you see, the land cover is shown on this map, shows a lot of European countries. There is no map for Ukraine here because Ukraine was not joined that initiative at that time. And the service provides a very detailed, complete information about land cover and the state of actual land use. And this global land cover is available in 100-meter resolutions over the world. It's a very substantial achievement, as for me, as a researcher of land cover. Actually, Ukraine has joined the so-called Eastern Partnership countries of Korean land cover pilot project. It includes Armenia, Azerbaijan, Georgia, Moldova, and Ukraine. And in June of this year, these countries finalized national mapping exercise for land monitoring services, because previously, as you can see, land and soil indices in environmental indicators represented by 0 parameters. So there was no information in such a big, well-developed agricultural country as you land and soil. It was nonsense. And from this year, Ukraine joined this initiative to product land cover information in the worldwide scale. So this place is also very interesting for me. This is so-called Global Land Cover Viewer by Copernicus Initiative, and it shows the south of Ukraine, where the river Dnieper falls to the Black Sea. And here is a place that is called the second biggest desert in the Europe, and that place is a subject of my research. My investigation was prepared 3 years ago about the time scale that shows the changes in region, because this is that dunes, that sand dunes that were surrounded by forests and some water bodies. And the evolution of this landscape is very well shown here in global land cover mapper, because you can see the changes and the transition from one type of land use to another, from one land cover to another. And you can see even the dynamics during the years. Another important problem is to have such kind of monitoring system as I show you on this slide, that will show land use dynamics and actual state of land use. Also, a very prospective direction for land use monitoring is use artificial intelligence. There is also pioneering eye tracks called Open Surface that investigated deforestation from outer space, from the space, and other initiatives. And even Microsoft has its own artificial intelligence that is directed on research in land cover mapping. It's also very nice for them. This investigation has a very long history, and that's only one example on such big area as China has. So they have a very good material on transitions of different types of land cover during the more than 20 years, as you see here. The same initiative is possible using Copernicus Land Monitoring Service for these years in Ukraine, because Ukrainian agriculture is dynamically developing now, and it needs some kind of policy of regulation, and it helps to understand the direction of growth in the future. Well, I will finish. I have 2 minutes left. Conclusions, short conclusions from my report. First of all, many of soil maps are out of date. They are too old to use them, and there is a great need to prepare newer maps with some innovative approach, with use of remote sensing techniques, drones, and so on. And that part of map that connected to soil degradation maps are in a special great demand, because this will show the actual potential of territory, of growing yield, and so on. The next, that the soil conservation measures will be connected with real agricultural practice, determining crop rotation and so on, that is possible for the stakeholders, for farmers and so on, to provide this kind of measures to improve soil parameters. And a lot of services for that are already present in Ukraine, and we already start them. And the one that is especially promising is Copernicus Land Monitoring Service, which from this year will improve the situation with land use and soil conservation in Ukraine, and will help to solve a lot of environmental and agricultural problems that we have now with present intensive use of Ukrainian soils in agriculture. Thank you. I finished my presentation. Any questions?
Thank you, Vyacheslav. On air. Microphone. Turn on, because your microphone off.
Yeah, okay, now,
great.
Okay, thank you. And I would like to thank Vyacheslav, very good presentation. And you mentioned about very good mapping and action plans, some related to some other countries and also including Ukraine. I think this is a combat to desertification, erosion, and environmental issues is very, very important. But my question is, in Turkey also, we've got very good action plans and some mapping related to soil and water resources, any issues we speak here. So my question is, what happened in the practically? Is it successful to prevent all the soil and water negative effects, all these? What is the situation government side and the NGO sides?
Well, that's the direct problem we have now, because that may be called the bullseye. That's the key problem in land use and land conservation. And still, we have no direct answer on these questions. I hope we will continue this discussion after the fourth presentation, because the time schedule says me that we should switch to the fourth presentation by Dr. Richard Stichauer from Pennsylvania. I hope you hear us, Rick, and are ready to start your presentation.
Yes, good morning, Václav. I can hear you very well.
Good morning in Pennsylvania.
Yeah,
good evening here.
To you, good morning for me. So can I share my screen to begin?
Yeah, sure. Yeah, you can, sure.
Okay, see if this works. Do you see?
Yeah, it works. We see your screen now. Yep.
Okay. Okay, so when Václav contacted me about participating in this roundtable a couple of weeks ago, my first thought was that you know, I'm retired now. I'm not doing any more research. I don't have anything to talk about. So, but then I thought, well, one of the benefits of being an emeritus professor is that I don't have to justify my position any longer to the university, since they're not paying my salary anymore. So I can just think about things and talk more broadly. So this is going to be a very much more of a conceptual discussion, not so much definitely not focused on any research that I have conducted before I retired. So I proposed that I would talk about this topic of sustainable agricultural intensification. This idea that we could meet the dietary demands of Earth's increasing population by increasing crop production, increasing crop yields on existing agricultural lands, and that we can do that while maintaining the productive capacity of that land. So I will also focus this talk somewhat on the sub-Saharan Africa region. So I'm focusing on this region because of the immense population growth projected for this part of the world, and then also the very huge challenges in this part of the world to actually achieve any kind of agricultural intensification. But I also chose to look at this region because I spent my childhood in Nigeria, and then as a young man, before I entered academia, as a young man, I spent 5 years in Liberia in West Africa working in agricultural development. That would have been back in the 1980s. So in the smallholder farms that we find in this region of the world, in sub-Saharan Africa, account for the vast majority of farms in the region, as well as the majority of the food production that occurs in the region. So it's really these kind of farms that need to be the target of any agricultural intensification. So the woman that you see in this image is one such farmer in Liberia. She's harvesting upland rice by hand, one panicle at a time. If you look closely in the rice here, you see cassava also is growing, interplanted with the rice. And You can also see oil palms, native oil palms that are preserved on this farm. So they have a integrated cropping system. Growing a local land race of rice with no inputs of fertilizer, herbicide, or pesticide, no mechanization. Her yields are probably 20% or less of what potentially could be achieved with improved varieties, use of fertilizers, or other nitrogen types of inputs, nitrogen or phosphorus, better weed control, better pest control. But on the other hand, of course, her practices have very, very minimal environmental impact and minimal degradation of soil quality, aside from the initial forest clearing and burning to establish this farm. So, the question would be, and then whatever soil quality loss did occur in that initial clearing is going to be largely regained in the 20 to 30 year fallow period that's going to follow harvest of this rice and cassava. So this is just kind of the challenge for sustainable agricultural intensification in this part of the world. Just one idea, one picture image of that. So let's begin with a definition of what SAI, or sustainable agricultural intensification, is generally understood to mean. It's a process or system where agricultural yields are increased without adverse environmental impact and without conversion of additional non-agricultural land. So I'm going to focus my talk on the ecological dimensions of SAI, but it's important to understand that this concept does also include economic and social dimensions, which are, of course, equally important. Our so-called three pillars of sustainability. So there's controversy over the end goals of SAI. It's hard to argue with these goals, but there is far less agreement and also a lot of debate on the exact means of reaching these goals, and the means of reaching the goals are often not very clearly articulated. But generally, these are going to include, the things that I've listed here: soil conservation, erosion control, soil quality management, crop rotation, IPM, improved varieties, livestock improvements, weed control, mechanization, and the list could be continued. So exactly how these would be achieved is again a source of a lot of debate, and I'll touch more on that debate a little bit later in the conversation. Of course, a number of our speakers this morning have touched on these different measures that could be implemented. So you laid a nice groundwork for this talk. So these are not new ideas either, of course. Farmers and researchers and government agencies and NGOs have recognized the need for soil conservation for centuries, if not millennia. This is just in 1934 in the United States, a WPA poster right after during the Dust Bowl to promote use of shelter belts. And of course, these shelter belt idea was taken from Ukraine at the time and Russia, where they had been implemented to control wind erosion. So certainly nothing new. And when I was teaching, I used to show this image to my class. Patrick Henry may not be familiar to anyone outside of the United States, but he was a famous Revolutionary period patriot in our country who's famous for for saying, "Give me liberty or give me death." But I would challenge my students that an equally important quote from Patrick Henry was, "Since the achievement of our independence, he is the greatest patriot who stops the most gullies." So this is back in 1776 time frame. So the need to conserve land and prevent erosion is certainly nothing new. Of course, we can go back into earlier times in Europe and the Roman empires and even earlier and find people who are talking about the need to conserve land, conserve soils, and preserve all of these vital functions. So back to SAI. It really has been around for a while. It kind of first came into vogue in the probably in the 1980s, but it really has been promoted by the Sustainable Development Goals of the United Nations. So most directly, the Sustainable Development Goals that most recently ones that were adopted in 2015. It relates most closely, of course, to goal number 2, to end hunger, achieve food security, and improve nutrition, and promote sustainable agriculture. But again, it also, SAI interacts with a number of other goals. So sustainable terrestrial ecosystems, sustainable forests, desertification, combating that, halting, reversing degradation, biodiversity, water, and energy. So, a number of the topics that our previous speakers this morning were talking about. So SAI really encapsulates each of these. And of course, graphics like this one showing world population projections are nothing new to any of you. I'm sure you've seen many variants of these. The one thing I wanted to point out, we are projected to get too close to 10 people, but most of that growth is going to occur in sub-Saharan Africa. If we take out the growth in sub-Saharan Africa, that plateau is much, much lower. So we have a tremendous amount of population increase there. Looking at that information a little bit differently, the proportion of the world's population that is going to be found in Africa will be increasing substantially. Currently, there's around 1 billion people on the continent, and by 2050, it will probably double, and there'll be 25% of the world's population. And then by 2100, double again, and will be just about as many people in Africa as there are in Asia. And of course, we often think of Asia as the world's population center. So critical to improve food production in this region of the world. We can find various projections of what population increase will mean for global food demand, and regardless of what projection you choose, of course, all of these show a substantial increase in caloric and protein demand. Projection from Tillman from the University of Minnesota. Tillman et al. Worked on this, where they put various countries into classifications. Here, the economic group classifications from A through G. A is the developed countries, United States, Canada, Western Europe, etc. G, the least developed nations, lowest GDP, and most of sub-Saharan Africa will find itself in group G. But they projected the changes in food demand, basically in these different regions, looking at the projected population growth of each and projected GDP increases over the time period. Basically, the bottom line is they end up with a projection that we need to essentially double crop caloric or crop protein demand. And if you other projections give a higher increase or demand increase if all groups were to reach the consumption levels of Group A nations. So Tillman et al. Give a somewhat lower projection, but nevertheless, doubling of crop demand by 2050 is still a very big requirement, a large goal that we would have to achieve. So how can we achieve that increase? So the possibilities, of course, are either we're going to increase land clearing and conversion of agronomic production onto forest or grasslands. So this would be what we call extensification. Or we can go the intensification route of production, increasing production on existing agricultural land, or some combination of both of those. And the question is, of course, what is the environmental and ecological impact of achieving this goal going to be? And so, increased land clearing, already about a third of terrestrial land is in agriculture, and most of the most highly productive land is already in agriculture with relatively little high productivity capacity land left to convert. And with no intervention at all, extensification is going to be the most likely pathway that would be taken in sub-Saharan Africa, with probably, with obviously severe consequences for natural areas, natural habitats, and many of the other ecosystem services that we rely on from soils. So again, just pointing out the need for some kind of SAI solution. Again, if we look at the sub-Saharan region, of course, it encompasses many different climatic zones. Number of smallholder farms in this region is somewhere around 33 million, representing about 80% of all farms in the region. And these smallholder farms do contribute about 90% of the food production in many of the countries in the sub-Saharan African region. There is, compared to most other parts of the world, there is a large potential supply of new land for rain-fed agriculture. In sub-Saharan Africa, some 200 million hectares that potentially could be converted. Of course, this means converting grassland or forest. Another hurdle in the region, of course, is poor logistics. About half that land is not well connected to commercial centers. And these are images, again, from Liberia, things that I experienced trying to work in the country, poor roads, poor bridges, just to name a few of the issues confronting the area. Of course, there is a tremendous yield gap in the area, the difference between existing current yields and potential yields. So as we heard earlier, Europe and North America have nearly achieved their yield potential on most agricultural lands. When we get down to Africa, the yield gap is tremendous. We're below 20% of potential yield. Again, these are images of smallholder farming in Liberia, rice and cassava interplanted here, and looking at ways of intensifying production through soil fertility management, through weed management, through other conservation measures. But it's important to keep in mind, again, that any approaches to intensification that we can consider will have significant economic and social disruptions as well. So in the lower image, I don't know if you see my pointer, but this mound right here, that is actually charcoal production. And that represents a significant income source for farmers who just cleared this land for the farm, converting the timber they cut to charcoal that is sold to urban centers for fuel wood. So going to a permanent system where this farm would be used indefinitely would cause some significant economic disruption, both for the farmer and for urban dwellers who rely on charcoal for fuel, for cooking. So many of, a multiplicity of issues that need to be addressed in any attempts to intensify production. So the implications of increasing food production by doubling food production by 2050, they are vast and they are complex. I'm going back to the Tillman paper that I mentioned earlier, and I'm not going to go into their methodologies, which are fairly complex, but Tillman and his co-authors basically projected the impacts of yield doubling on various issues of potential for land clearing, potential for greenhouse gas emissions here. So in the first column, we're looking at yield increases versus global nitrogen. So they're regressing yield against global nitrogen use. Nitrogen is not necessarily only fertilizer. It could be better management of manures or legumes to increase nitrogen inputs. And they're looking at this global nitrogen use against yields, against land clearing, and greenhouse gas emissions. What's superimposed on this are, if the bottom line here is if we proceed on a trajectory of our current technology, as we increase nitrogen, we can increase yield somewhat. If we have some improved technologies for the same, we get bigger yield increases with similar nitrogen. With technology transfer and adoption to places here in Africa, we can get substantial yield increases for smaller amounts of nitrogen. Combination of technology and adoption, technology improvement and adoption, we get the largest increases. So these are their projections on yields. Looking at the same projection on land clearing, basically we can achieve this doubling with the technology improvements, with transfer and combination again. Combined, we get much less demand for additional land to achieve the same level of production. Likewise with greenhouse gas emissions, of course, substantial greenhouse gas emission from land conversion, and if we avoid the land conversion, we can achieve this production with much less greenhouse gas emissions. The other column here, figures D through E, are basically looking at 4 different potential trajectories to achieve this yield increase. The black arrow indicates if we continue along our current sort of trend or pathway versus a land sparing approach versus just relying on increased inputs, again using nitrogen as their indicator, and then a nitrogen minimizing approach. So here again, just if we sort of rely on current trajectories and don't do anything, we're going to get minimal yield increases and big increases in global nitrogen. Land sparing gives substantial yield increase with little change in nitrogen. And likewise, clearing, land sparing approach, so an SAI approach gives us a minimal demand for additional cropland while achieving that yield increase. And likewise, minimal additional greenhouse gas emissions. So the bottom line of this Tillman projection is, strongly indicating that an SAI type approach has the greatest potential for achieving this doubling in global crop production that we definitely need to have. However, projections like this are global in scale, and they pay no attention to some of the more detailed things that we would have to deal with. So I already mentioned that, but so how can we implement this in different regions of the world? We know we have vast differences in soils and climates and infrastructure, social structures, and so on. A paper like this one kind of covers all of those local issues, those local differences, and I think we have to begin to address those concerns if this is actually going to be implemented. There's also, when it comes to implementation of any kind of sustainable agricultural intensification, there is a great debate on how that should be implemented. And a recent paper by Marshall and Commanda really explored this. And so in academic circles and NGOs, we have this debate that looks at basically between what we call the sustainable agricultural intensification cap versus the agroecological intensification cap. So, broadly speaking, the SI group is often promoted by governments, by private sector agribusiness, international development institutes. It involves increased use of fertilizers. GMO crops would be tolerated. And pesticides could be used, of course, all with the goal of minimizing ecological impacts. But nevertheless, that would be opposed by the agroecological approach, where fertilizers should not to be used or minimally used. GMOs would not be tolerated, and so on. And basically, the Marshall and Commanda paper concludes that in reality, there are more synergies than differences between these two camps, and that really to move forward, we have to the synergies between them rather than focusing on this debate of the exact philosophical approaches. And again, going back to my own experience in working in sub-Saharan Africa, these debates might rage within academic circles like our own here this morning, among NGOs and international development institutes. But in my experience in working with as farmers, smallholder farmers in sub-Saharan Africa, it's a non-debate. They just want to know how they might be able to improve their productive capacity and improve their livelihood. Our debates are really very secondary to the people actually working the land. I think one approach to bridging this debate and actually beginning to successfully implement SAI is this framework proposed by Schulte et al. These are researchers from Ireland, but they propose a functional land management approach. And so basically, Schulte et al. Say, we all recognize that soils, in addition to being somewhere where we produce crops, soils provide vital ecosystem services. We typically list provisioning services, regulating services, supporting services, cultural services. And each of these, we have different things that we think about soils doing for us. And again, Natalia talked about some of these, owners have talked about some of these. And basically, we need to recognize that all soils provide these. So soils, Schulte et al. Say soils are multifunctional, but they emphasize that while in principle, all soils perform each of these functions simultaneously, soils differ in their relative capacity to perform each of these functions. So while one soil may be particularly well suited for agronomic row crop production, it may be less suited for carbon sequestration. It may be less well suited for water purification. It may be less well suited for some other thing. And some soils are going to be more well suited for natural habitat, aesthetic value, etc. So soils, in fact, are multifunctional. And Schulte et al. Proposed we need to think about this in the context of functional land management, that we utilize land and management such that the total suite of functions is maximized. So each soil performs the function that it has. So this would be implemented on a farm scale, a district scale, even a national scale, where we look at not just the production capability of soils, but the entire suite of ecosystem services, and in a given region, determine how land use should be allocated to maximize each of these ecosystem services. And I think
1 minute to finish, please. One minute.
Okay, I'm almost finished. Thanks. I think that we can begin to bridge this divide between the agroecological approach to intensification and the traditional SAI approach by adopting such a functional land management approach. So there are, again, to implement this, we need to look at, we can manipulate soils by direct alteration of properties. So things like cultivation, nitrogen use, irrigation, cultivation, or land use change, putting land into various types of uses. So we can, if we do this, I think we can begin to meet the twin challenges of food security and environmental sustainability. If we, again, try to maximize these soil functions. Doing so, of course, will require tremendous investment in knowledge bases. And Slava was talking about the Copernicus system. We need a tremendous increase in soil and landscape knowledge, mapping capability classification, functionality classification. We'll need tremendous programs to incentivize farmers to adopt such programs. And we need tremendous investment in knowledge and technology transfer to implement this. Okay, I will stop there. I believe I'm out of time.
Thank you so much, Richard. Great presentation, great report. Any questions to Richard? Natalia, please, your questions. I see your hand. Switch on your microphone, please. Yeah.
Okay. Yes, thanks, Richard, for a very interesting presentation. I would like to ask you about this. I've heard a lot about it when I was a student in Ghent University in Belgium. They do a lot of projects in Africa, and just I'm interested in your opinion. So, for instance, they developed some soil conservation measures with scientists. I don't remember the country, Niger or Nigeria, but somewhere there. And then when they came to farmer with these ideas, they don't like to adopt that at all because of their religious belief. So how to overcome this problem? I mean, maybe it's not so global for this, for this region, but how to do it? So it was done a lot, but actually it is not adopted. Yeah, it's not a problem of scientists. Yeah.
Thank you for that question, Natalia. It's an excellent question and a very real. Again, it requires technology adaptation. Requires people who are local to the area where you would like to see adopted. They need to be involved in the development and modification of any technology or idea so that it fits the local culture. I could give you stories of similar experience we had in Liberia. I tried to introduce lowland paddy rice cultivation on a permanent location. And the technology, the system worked great, and farmers were capable of doing it, but it was a major social disruption because traditionally the men go and clear the forest, burn to make the farm, they burn the wood, they make the charcoal, they build a fence. The women do the planting, the children do the weeding, the women do the harvesting. But now suddenly there's no land clearing. Once the paddy is established, it's there. It's perennial. It's not something they do every year. So the men have nothing to do anymore. And so to figure out these social dimensions is just as important as the technology. Also, I tried to bring in some improved cassava varieties that were resistant to a cassava mosaic virus. And the yields were 5 or 10 times what the local farmers were getting with their local varieties. But they didn't taste right. They didn't taste good, and they wouldn't use it. So again, those kinds of issues are real, and to work with local people to implement these things and adapt them, excuse me.
Yeah.
Okay, thank you. Any other questions to Richard?
May I ask a question?
Yes, sure. Dr.
Okay.
Melchete, please.
Okay. And the world, also I would like to ask a question, and I would like to focus on as small remarks related to my question. The world today faces an increased stress on increasing population, as mentioned Dr. Richard. And this population growth, urbanization, climate change, and mismanagement of soil and water resources. And of course, this is the food security and water security is related to directly the soil security. My question is, degradation and declining and productivity agricultural soil is decreasing year by year. Questions, what do you think directly and practically solutions? I know that each solution could be changed, each countries and each local areas. But I know that even if there is good and appropriate mapping or action plans, and what will happen in practically, because the main question is that it's very difficult to improve or to prevent all the negative effects on the soil and water resources. Thank you.
I'm not sure I got all of your question, Owner. It was hard time hearing, not a good transmission. But if I understood your question, I think, yes, there are certainly the potential for land degradation with intensification. I think if we go back to that Tillman paper, the one strong message is if we attempt to do nothing, we will end up with the worst scenario. So we will have the most land conversion, the most land degradation, and the least increase in yields. So I think that should motivate us to work diligently for technology transfer that will minimize land conversion, that will, again, assess soil capabilities for various essential services that they provide, and again, target production to the lands best suited for that, while converting other land to more for other uses. We, again, in the more developed world, we have a long history of doing this. In the United States, we have the conservation program where farmers are incentivized to take susceptible land out of production and put land into permanent cover, either pasture or let it go back to forest. The government is paying the farmer to take that land out of production, so that degradation of that land, the erosion primarily, stops. Well, we have to have similar efforts, I think, globally, where we have incentivization for farmers to focus their production on the land that is best for production and keep other lands in natural habitat or other land cover uses that will conserve the productive or conserve the ecosystem service of that land.
Okay, thank you. Now we are transferring to discussion, and if any of participants have a will to take part in discussion, please, you have a few minutes to discuss the report, the topics, please.
May I?
Yeah. No,
No, after you.
after you, yeah.
Oh, okay. So thanks a lot. I really enjoy all talks today. I just, so maybe this is a very, very short question. I'm just really interested about the share of drip irrigation in Turkey. So because I know there's flooding and drought and so on, of course, it's water demanding and it can lead to salinization, but is not it be profitable to apply drip irrigation if it's very expensive? I mean, to pay for water and to pay for land degradation later. Yeah. So this is really.
Okay. May I respond? Right.
Yeah.
Okay. That's a good question. Thank you. As I said before, if you apply any drip irrigation systems, we can save more than about 30% up to 50%. It's very, very important high water saving. The problem is mismanagement. Even if you got any good projections and planning, the problem is management and application during the practically. And second things, as I said before, the government subsidize 50% of the total investment cost. But it's in the practical is very, very difficult. But we are trying to improve and increasing of the percent of the pressurized irrigation system. Fortunately, year by year increase. But of course, this situation, it depends on the geographical regions, especially in western and middle of the Turkey is a good successful about that. But south of Turkey is farmers mostly intend to use and surface irrigation because they believe and the response very high to yield. So it's a very complex situation. It's there is no any one solution because there are many sides of these problems and local problems. Some and as I said, the education level farmers and the history, religion sometimes, and something like that. So unfortunately, all the world and also in Turkey, we cannot save properly soil and water resources. We have to save the situation. Maybe you can do appropriate good laws and regulations, but practically sometimes it's very difficult. For instance, I can say something like that in the before 30 years ago in the south of Turkey, the government constructed a very good projects and pressurized projects, but unfortunately, most of the farmers all collapse these systems because they don't want to use and maybe they don't know properly, even if there's some extension service good serve for them.
Okay, thanks. Yeah. I agree. This is not so easy.
Okay, right. Thank you.
Any other thoughts? Any other person who wants to participate in the discussion now? Maybe not the reporters, but the other participants. Okay, in this case, I will summarize today's event, and as we hear from all reports, the problem is topical all over the world, and it is highly connected with such problems as food security and social stability. It's very important to take attention for this problem, to keep constant or sustainable development of the society, and this problem should be solved as on global as on regional level. So I am very glad for such a high level of information we obtained today on this problem of land conservation in the world and cases in different countries. It was very interesting for me to again visit in my mind Turkey in Dr. Anarchitin visit. I was very glad to see Natalia again, as we are all friends, and it was very big pleasure for me to see and hear Richard and his very interesting and deep report about Africa, and not only Africa but about food security all over the world. It's a big problem, and we already are there in that problem. It's very topical and very interesting report. Thank you all for that. I hope that we will continue such kind of events in future, and I hope that in the nearest future we will be we will have opportunity to see each one not only by WebEx and distance means, but we will hope this situation will improve soon. But we still should hope, I think.
Let's pray to finish pandemic.
Yeah. But it's very important to keep such kind of communication even during the pandemic.
Of course, yes.
And you can all be glad you're not in the United States.
So we hope that all of you enjoy the participation in this event. Thank you so much for joining from different countries, different